Hello, today we are going to talk about Invoke for the .NET framework applied to the programming language C#. So the C# programming language and .NET framework is a managed programming language, has a cross-platform capabilities, and still sometimes you need to call C-style DLLs or C-style shared objects on other operating systems than Windows. In this case, we will talk about the Windows API, which is a series of DLLs, dynamic link libraries such as shell32, user32, etc. .dll, which export functions C style structs, so structures, and enums, which can be used from any other programming language. So it's easy to use a C DLL from other C language projects, but also from C++, and then using the feature of using C language DLLs from a specific language, you can call those DLLs from other programming languages. So Delphi has a mechanism for calling Windows Win32 API DLLs. C# has a mechanism which is called Invoke. Java has a mechanism. Python has such a thing, PyWin32. Okay, so the API DLL in this case, the Win32 API DLL, is called user32.dll, which lives in C colon Windows System 32. Where are you? User 32.dll. So it's this file. You can look at this file using dependency walker. Let's install dependency walker and see. Okay, so dependency walker is the application that I have usually used in order to see DLLs, what symbols do they export, what symbols do they import, what are the DLLs on which this DLL depends. So depends.exe or dependency walker, dependencywalker.com 2015. And then there's an open source C# rewrite of dependency walker called dependencies.exe. Okay, so let's try the new one. Dependencies, which is written in C#. Download here. Compressed zip folder, yes, what I want. I prefer executables that can run from zip files without any installer. Temp bin save. Okay, let's see if my application is a 32-bit or a 64-bit application. So the operating system is Windows 10 64-bit. Where does it say such a thing? So there's processes both from C:\program files and processes from C:\program files x86. There was a column that you can add to task manager task, which says if the process is 32-bit or not. This thing platform. Okay, says 32-bit, and most of my processes are 64-bit. Let me run the application and see if it's 32-bit or 64-bit. So console app1.exe from today's directory, and it's 32-bit. So let's change that. Properties, stop, and it says that there's two solution configurations, build configurations. There's release any CPU and debug any CPU, and the only project in this solution has two build configurations, debug any CPU and release any CPU. But then both build configurations have the checkbox prefer 32-bit. So let's uncheck this one. For all configurations, any CPU, I uncheck the checkbox prefer 32-bit. I'm running the application, which will also build it. Let's look and see if now it's 32-bit or not. So console app1, and it's 64-bit. Okay. So let's look at the dependency walker. Dependencies, the new one, the new application. So right click, 7-zip. Okay. Where are the executables? How many executables are there? I sort by extension. There's dependencies and dependencies GUI. Dependencies seems to be a command line application, and dependencies GUI is what we want. Okay, so let's go back to our source code. So we say take the Windows API, Win32 API, DLL user32.dll, load. So this is a C style DLL, which exports C style functions. And inside of this DLL, find a function that is exported with the ID as string message box. And then load this function, probably using load library, the Win32 API. And then the signature of the C exported function will be, I don't know, int32 message box. This is probably void pointer. This is probably lpc tstr. This is the same, and this is uint32. Okay, so let's actually look at this symbol message box exported from the DLL user32.dll. So we go to C:\Windows\system32. We find user32. This thing. And we'll drag and drop it over dependencies, x64. Okay. Let's look at this DLL. Depends at load time, not at runtime, on the following other DLLs. So there's Windows API sets, which are these things. So it says, as of Windows 7, Microsoft introduced the concept of Windows API sets, which is a form of DLL redirection. Okay, so we can see that there's a DLL which is called API -ms -win -core -localization, and then a version.dll, which redirects to kernel-base.dll. And then there's API ms win core registry, which redirects to the same DLL. And API ms win core heap, which redirects to the same DLL. So in the right hand side we have the Win32 API, so the DLLs that we know from Windows 98 2nd edition, the Unicode ones. Okay, in the left hand side we have the Windows 7 style Windows API sets. Okay, so the ones in the left hand side are way more, and the ones in the right hand side are way less. So for instance, kernel base 1, 2, 3, 4, 5. So just one Windows 32 API DLL, which is kernel base, and the Win API sets, there's 5 of them in this case. 5, even more. 6, 7, 8, 9, 10, 11, 12, and on. What does this one, API ms win core registry DLL do? Well, it only exports Windows registry Win32 API functions. So reg create, reg open, reg close, reg delete, reg set, reg query. Just the Windows registry functions. Then heap does only heap functions, so global alloc, global free, and local ones. Library loader, load library XW, which is the most important function if you want to load at runtime other Win32 API DLLs. And then the next one is get proc address, which, so this loads an existing Win32 DLL into your process at runtime, and then this returns a handle, and then using that handle and the name of the function, you get a pointer to the function using the function get proc address. Okay, so let's keep the Win API sets and get back to user 32. Let's look at the exported functions. So the exported functions are in here at letter E, modules exports, and the imported functions are at PI. So user32.dll exports these functions. Let's sort them by function name. So activate keyboard layout, add clipboard format, add visual, adjust window, align rect, allow foreground, allow set, animate window, any pop-up, append menu, etc. These are the functions exported by user32.dll. Out of these functions, so between these functions, we can also find the one that we're using from C#, which is called message box. Let's look at that function. Letter M. So there's not one exported function, there's 3. There's message box A, which means message box ANSI or single byte string, null terminated string. And then there's message box W, which is the message box for the Windows style string type LPWCSTR. So the 2 byte per index. So UCS 2, aka UTF-16 little endian. So message box W and message box A. Okay, we do not specify the name of the exact name of the exported function. We do not say message box A or message box W. So how does the .NET Framework know which of these two to actually load? There's no function exported from the user32dll file that's actually called message box without an A or a W. Okay, so user32dll exports just to symbols message box A or message box W, totally does not export the symbol message box. So let's see how this thing works. So the magic is this annotation, so char set auto. Let's look at it. How do we do that? So DLL import attribute character set field. Okay. The example is with a message box, exactly what like the way we do it. And the possibility for the char set enum are ANSI, which is 2, auto, which is 4, none, which is 3, and Unicode, which is 3. Let's go to definition of char set, control click, char set. So it's not actually flags in enum, that's why it doesn't have the values for flags and has a 3 in here. So the values are ascending and continuous, so 1, 2, 3, and 4, not 1, 2, 4, 8, etc. for flags. You should not use the value none. This thing ANSI so this thing ANSI is for the functions with ending with uppercase A. So that means let's look at the Windows C style string types. Okay, so the Windows C style, so the in the C programming language, among the types for strings used in the Windows operating system and its kernel and accompanying Win32 API, the first two ones are char pointer, which is also called, let's write this thing down. So char pointer is also called LPCSTR, is also called if it's const. and their console. Let's make this const. This, if you do not define the C macro Unicode, and then the alternative is const this thing. Which is called LPCWSTR and LPCESTR if you define the macro, the C macro Unicode. Okay, let's save this. Save as. Okay. So what does travel through these types? Well, in here there's only one thing, which is called UCS2 or Windows style UTF-16 2 bytes little endian without byte order mark. Whereas through here there's two things that could travel. Might be a plain ASCII or where is the other thing? This thing, MBCS. Not really. So plain ASCII meaning 7-bit strings or extended ASCII meaning 8-bit strings 8859 minus 2. Okay, so this is a 8-bit single byte character encoding for Latin alphabet number 2. And Windows has this thing which is called Windows code pages. And in this case, it's this thing. Okay, and the list of Windows code pages. Where is it? Okay, so this thing. How to get covered. CHCP. System info. Where is the code page? Okay, so it says that the active code page is 437, which is what? Oh, this is for DOS. Local English US, English United States. Okay, so I do not know how to determine what's the current Windows code page when we use 8-bit strings. It certainly can be changed per Windows user, per Windows installation. Windows is translated in various other languages than English US. You can install additional language packs on your Windows installation. Okay. So back to dependencies. Now message box W is for this case. And this is the case for the other one. A. So message box A is not necessarily non-Japanese. So you can pass Japanese strings through message box A if you use MBCS, and if MBCS is okay and enough for you, if it has enough characters. Then you select a Japanese Windows code page. So Shift G is code page 932, for instance. Okay. The transition was made from this category to this category. So all modern applications, on all of the applications that I worked for the last 20 years, we always prefer this to this. So if you write a C or C++ programming language application, we try as much as possible to use only this set of API functions. Message box W, not message box A. And when we interface with the Win32 API, that's when we convert the native string type, the canonical string type of the specific programming language, to this type, to const wchar t pointer. Okay, so wchar t is 16-bit to byte, to double byte type. Okay, and then back to the enum char set. So the none should not be used. You use ANSI instead. And ANSI is multi-byte character strings. The Windows code page on Windows and UTF-8 on non-Windows. Okay. So it could be single byte or multi-byte. So this is actually the charset.ansi. And this other branch is for charset Unicode Marshall strings as Windows style Unicode 2-byte character strings. So these are not Unicode, are Windows style UCS2. So charset.unicode. Okay. And then the special one is value for auto. Automatically marshal strings appropriately for the target operating system. See charsets and marshalling. By default, C# and Visual Basic mark all methods and types as ANSI. Okay. So in C#, if you do not specify charset, it will be charset.ansi, which is which this thing is UTF-8 on Windows, so a 1 byte, whereas on Windows, depending on the code page, might be single byte or MBCS, multi-byte character set. Okay, so that's ANSI. Therefore, whenever we import a well-behaved non-Microsoft, non-Windows style applications such as, I know, zlib or the image formats libpng, libjpeg, turbo, etc. Being a non-Microsoft, non-Windows application, that will prefer to use UTF-8 as its native C-style string type, so const char pointer but UTF-8. So when you import that using pinvoke towards C#, you will need to use charset ANSI, even on Windows. When you import a Win32 API function, then if you're on C# and if that function has parameters of types, arguments of type string, then you must use charset Unicode in order to get the function that we prefer, which is the function ending in W, not the function ending in A. Okay. So in C#, if you import using Invoke a Win32 API function, do use this thing. Okay. So the functions that have as parameter or as argument a string or many have are exported twice from Win32 API DLLs, one with the suffix uppercase A and once with the suffix uppercase W. But for instance, for the function message beep, which doesn't have any string type arguments, there's no need to export it twice. That's why it's not, it's only once exported. So let's look at message beep. So this is a API function from the DLL user32 DLL and from the header winuser.h, but you should include the header windows.h in the C programming language or in the C++ programming language. And inside of the API set, ext ms win anti-user misc DLL. Okay, the signature of the function is function name, which is message beep. It returns a Win32 API style bool, uppercase bool, and has just one parameter, which is a uint. So this is not string, this is not string. There's no reason to have a message box, a message beep W and a message beep A. Would not help at all. So when you specify charset Unicode, it will see that there's no export message box message beep W. Therefore, it will import this function message beep without a W at the end. Okay, so it's always safe to use charset Unicode when importing from C# using Invoke a Win32 API function. When you're importing a non-Microsoft DLL, that's when you're going to be extremely careful, because most cross-platform DLLs don't actually know about this thing, or this thing, or this thing, or this thing, and instead go straight to the type which is better suited for everything, which is single byte 8-bit UTF-8. Okay, so the Windows style const wchrt pointer is something very exceptional in the real world, and I guess that it will disappear once Win32 API will start to not be as popular as it is right now. So this double byte thing exists solely because of Windows. Okay, so let's go back to the source code. So we specify charset auto, which means what? Charset auto automatically marshal strings appropriately for the target operating system. Which is what? Which is this thing. So on Windows .NET Framework, there's it's going to be wchrt. On .NET 5 and above, it's going to be char UTF-8. I totally don't understand what's happening here. So auto on Windows is the same thing as Unicode. That's what I understand here. Okay, so charset auto is the same thing as charset Unicode. For Windows NT and up, it's charset Unicode. Okay. Let's also import the function named the message beep. So how do we do that? Invoke, Control V, message beep. So it takes us to the correct website, which is called pinvoke.net. And in here we can find the signature for various programming languages that are supported by .NET Framework. We care about C#. So it says DLL import user32.dll, return Marshall as unmanaged bool, and static, so it's missing the visibility, extern bool, message beep. This is the name of the function as exported from user32.dll. And this is the conversion of the C style signature to C#, including this part. Okay, let's look at the function. Its signature as documented by Microsoft. So it's message beep function from winuser.h, okay, from which DLL is it exported? From user32.dll, so that's what we have in the attribute DLL import. The name of the function is message beep as documented by Microsoft and as we can actually see using dependencies. Then the rest of the signature, so it returns uppercase bool. Windows C bool. Okay, let's find out what bool is. So bool is a C programming language type defined by Microsoft and Windows inside of the header windef.h, and it's actually an int, which means 32-bit. Okay. And then what is true and false? These are probably C macros. So defines. Let's see if we can have access to this function windef.h. This thing. The Wine programming open source project is a open source from scratch free reverse engineered implementation of the Win32 API DLLs, among many other things. So there we will have the source code of user32.dll, but not the source code that was written by Microsoft. Instead, source code which behaves in broad lines similar to user32.dll. Okay, so there exist inside of the Wine open source project also all of the Win32 include files, including windef.h. So let's look for true in here. So says that true is 1. So this is a C style macro. And false is 0. Okay, where is bool defined? Bool is defined as an int. Okay. Okay, so let's see what parameters does message beep have. So we see return value is in fact int32 signed. So it's a bool with all uppercase. And .NET Framework's Invoke machinery will convert the return type to the canonical C# bool type. Okay. And if we look at the message beep signature as documented by Microsoft, the only parameter is uint utype, which utype is a unsigned int 32-bit, but its possible values are defined in an enum. So this is in spirit an enum, but in reality it's C programming language macro defines. Okay, so MB icon asterisk is defined as MB icon information, MB icon exclamation is defined as MB icon warning, MB icon error is defined as 10L. In hexadecimal. Okay, so the two ways of surfacing the Win32 API function using pinvoke in C# is either to say that its argument has the type unsigned integer 32-bit, or to actually define an enum with all of these values and then pass that enum to the function as the type of the only argument utype. Okay, so let's go back to pinvoke where this beep type probably is defined. Okay, we can find it in here. Control C. Let's separate the function exports from Win32 API. Let's separate them from the enum definitions. And let's see what the name of this enum should actually be. So it says message beep utype. Okay. And in here they're defined as MB icon asterisk, MB icon exclamation, MB icon error. So these things and MB OK. So this is another enum not for beep, it's for message box icons, and this is for message box buttons. Okay, so let's start by naming the type message beep type. Anyhow, the type should have an uppercase in here because we invent the type name. This type name is not defined anywhere, so there's no reason to make it not standard by starting with a lowercase letter. So be camel case instead of Pascal case. So Pascal case starts with an uppercase letter and camel case starts with a lowercase letter. Okay, listing message beep. Okay, then let's look at the actual type. So the type is uppercase uint, which we do not know its size. So uint is unsigned int. This thing. And the signature of the function is this thing. And the definition of bool is type def int. Okay, and the possible values are, let's start with this. Okay, and the types for Win64 APIs. So we need the size of int. Windows 64-bit size of int. Where do we find this thing? So this int is unsigned int. This thing. Signed int. Like this. And the sizes for Microsoft C++ 32-bit and 64-bit compilers. Int is always 4 bytes. Okay, so this is 4 bytes. And this is 4 bytes. Okay, back to where we were. We need the C# types. Okay, here they are. So we need a unsigned int 4 bytes. Which is unsigned 32-bit integer, uint. Okay, and then for bool, which is in fact C style int, which is 4 bytes. signed, which is C# int. Okay. So the parameter of message beep is an enum, but this utype is uint all uppercase, which is C# uint. That's why we define the enum as being based on the type C# uint. Okay. Then the possible values of this enum are where are you? In here. So 0x and then 8 FFs is a simple beep. If the sound card is not available, the sound is generated using the speaker. So speaker in the sense of PC SPKR. This thing. So this thing where it says speaker, this is the connector to the connectors on the motherboard, and the speaker looks like this, a circular piece of plastic, and inside there's a actual electronic speaker. Okay, most motherboards nowadays do not have a PC speaker, or you can add it after you buy the motherboard. Okay, so back where we were. Then there's the next value. So let's put the values in correct order. The first one is 0, which is MBOK, so not okay. Let's actually use the exact strings as they exist in the Microsoft documentation. So this is the first one. We could use it like this. The sound specified as the Windows default beep sound. So I'll remove all of the doc strings. Whoever is keen on knowing the documentation for the enum values is free to use the Microsoft documentation, search for message beep, and then the possible values of the parameter utype will be available. Okay. So what's the first one? MBOK. What's the next one? So this thing is a okay, so there's many values which are mapped to 10L. So let's do that. So 10 is MB icon error. We cannot define more than one member of the enum having the same value, right? Okay. Then 20. This question is this thing. And then 30. exclamation. And then 40. Which is information. Okay. MB icon error. So we have values for 0, 10, 20, 30, 40, and this one, the last one. Which is simple beep. Okay, since the Microsoft documentation does not provide a hint how we should name the member of the in a message beep type for 8Fs, we're going to use a string that's generated from the documentation and which respects the C# coding guidelines, which say we should use Pascal casing here. So uppercase S, uppercase B. Okay. Let's see if we can use this function. Message beep. And as parameter, strong typed enum. Let's go with exclamation. Run the application. So this is a virtual machine, does not have a beeper, a PC speaker. Okay. So we managed to import using pinvoke two functions from the Windows Win32 API and one enum. We like this signature. We have reviewed this signature. And now we need to decide if message beep sets last error, does not have strings, so no need for any char set. Whatever char set is set here will be okay. And then for last error, let's see if it sets last error. If the function fails, the return value is 0. To get extended error information, call getLastError. So this function actually sets, calls the API Windows Win32 API function setLastError. So we actually need to add this parameter. In here, Control S. Okay. What does setLastError do? It says DLL import attribute setLastError field indicates whether the callee, so whether the exported function message beep in our case, calls setLastError, and it does call it. Okay, because it says the documentation of the message beep function says that it returns a bool, and if this bool is 0, which is false, then you will need to call the function getLastError to get additional details about the error. How do you do that in C#? It's like this. If the function, let's save the result of the message beep function. Okay, and if the function has failed, then we should inspect the value that the API function message beep sets using the function set last error. If this field is set to true, the runtime marshaller, so the .NET Framework Invoke engine, will call getLastError immediately after it actually calls this message box function from the user32.dll. So it calls that function, immediately calls getLastError to save the error, which is an integer. Where are you? So getLastError is a function that's exported by the DLL kernel 32.dll and does not have any parameters and returns the word. Okay, let's see what this dword thing is. So dword is a unsigned long, and a unsigned long what is an unsigned long? So dword is a 32-bit unsigned integer. So this is 4 bytes. And in C#, this would be uint. Okay, back to where we were. Let's see what happens. So getLastError is being called by the marshaller and saved somewhere. Why you want to do this? That because once the C# the .NET Frameworks engine calls message beep, message beep calls setLastError, and you need to immediately call getLastError in order to fetch that integer. Otherwise, any other Win32 API call, function call, and there's millions done by the .NET Framework engine, might overwrite the integer that's set using setLastError. So it's just to not lose it. Do we want to not lose the value that message beep function sets via set last error? Yeah, we want to not lose it. That's why we need to specify set last error equals true. And we do both for message box and message beep. Okay. This information is kept by the .NET Framework and accessible using getLastWin32 error. Okay, so let's do that. So it says Marshall getLastWin32 error. And returns an int. Okay, and then we, for instance, show a message box with this thing. We keep the title and we edit the body. And the string that I usually compose out of the last error is mostly the same. It's the name of the function. So message beep has failed dot get last error has returned the value of the last error. Let's actually have this as a local variable. Okay. Let's run with the debugger. Okay, so a result of message beep is true, which means the API function message beep has succeeded and has played some music, which I cannot hear because I'm in a virtual machine connected via remote desktop protocol client, etc. Okay, let's invert this just for the sake of debugging. Okay, so in case of success, we call Marshall getLastWin32 error, which will look inside of the static storage, I know, thread storage or something where the Invoke engine will store the value. So what the Invoke engine does, it calls the Win32 API message box immediately, then calls the API function get last error and stores the returned int from the function get last error. So now we have access to that integer value, which is 50, which might be a value from set by the API function Win32 API function message beep or by another one. We do not know which. So between calling message the Win32 API message box and the Win32 API function message beep, there's hundreds of Win32 API function calls. We do not know exactly what the .NET framework does between lines 36 and 38 on our thread. So it might do anything in here between this line and this line. So one of the Win32 API functions, which might be this, but might be a million others, has at one moment called set last error with a value of 50. So what we get here is the 50 integer, but we do not know who set this integer, which Win32 API function has actually set this 50. That's why it's important to make sure that the previous function has failed and always calls set last error when it fails. And only then you should call Marshall get last Win32 error. Okay, otherwise you get random interesting integers, such as this 50. Okay, so the error text is message beep has failed, get last error has returned 50. And you get bonus points if you don't repeat yourself when you say message beep. So if you can take this thing and insert it into this string. Okay. So this is a message box, which is again a Windows 32 API call, which is this one, with a given title. This 0 says that this function, this window does not have a parent window. The title is set here. The body is set here. And 0 means, MBOK probably, which means show just the default OK button. And you can close the message box either by pressing right click on the title bar, anywhere on the title bar, and go close, or Alt F4, or click on this button, or click on this button, or press the escape key. And additionally, message box has another functionality, which is that you can copy the text by pressing Ctrl+C. And looks like this. So a line of minuses, then the title, line of minuses, the body, line of minuses. All of the buttons. So you can have in here the button yes or OK, or OK and cancel, or cancel, etc. Then a line of minuses. Ctrl+C, the standard shortcut for copying things in Windows. Okay, let's fix this. And now we are kind of, this signature is pretty okay, but then this signature, we're not sure if it's okay. So let's actually scrutinize this pinvoke signature. Okay. So we go to pinvoke show message. This is the way we search on the internet. It takes us to pinvoke.net message box, which says DLL import user 32 set last error through char set auto. Okay, public static int extern message box int ptr hwnd string text string caption uint type. Okay, so let's actually go at the definition of a message box, the way it's documented by Microsoft, and see if we like the signature. So it says return type int. So this is the C programming language type int. So Windows style C programming language int type, lowercase int. So it's the same thing as C# int because it's 4-byte signed. Okay, then message box, the exact name, the name of the function. Again, because we use char set auto, it will find the function message box w and use that. Because char set auto means on Windows use Unicode. Next, the other parameters. So if the Microsoft and Windows documentation uses a certain identifier, then that's what I'm going to use in my pinvoke. So if it says a message box with this capitalization, then that's what I'm going to use. I do not know if C style exports are case sensitive or not. They are. And then these identifiers for parameters are totally not exported by DLLs. So we could use any identifier for parameters. Still, I prefer that we use the exact same identifiers as the documentation of the API, Win32 API functions. So if it says HWND with this camel casing, then that's what I'm going to use. Okay, and this is LP text. LP caption, and this is utype. Why do I do this? Because these things are greppable. If you go message box space lptxt on the internet like this, then you know what the results will be. Or if you search these things on the, I don't know, on GitHub. It's going to work correctly, right? Or if you're going to search on the entirety of GitHub. I'm not sure how you do that, but okay, so it's grabbable, it's searchable, it's the canonical name, don't invent new things. Different people, when they write pinvoke over message box, will rename these things in different ways, so don't do that. Use the exact original name. So HWND, LP text, LP caption, utype. Okay, then let's look at the types. So we know that this is message box W. How do we it like this? So this is message box W, which is this branch, which is charset Unicode, which is UCS2, Windows style UTF-16 2 bytes, which this is LPCTSTR. So we don't need to do anything extra. LPCTSTR, this thing, is known by the Invoke engine. It knows that it's this, it knows that it's this, it knows that we're at charset auto and charset Unicode and that we're running on Windows. So it does the correct thing in here. Okay, let's use the canonical type, so lowercase s for strings. Okay, we did this too. Next is this uint. So uint is 4 bytes unsigned int, which is C# uint. correct. The parameters are input, and then this guy remains. Okay. So H, W, and D. Invoke H, W, and D. Let's see how this thing is done. Let's look at the type as defined in wine. It's a declare handle, and the declare handle is what? The declare handle is not defined here. Okay, so I don't know where to take this thing from, but I know that the Invoke engine does the correct thing, which is convert HWND to int PTR. Okay. Okay, so int PTR is a structure signed integer where the bit width is the same as a pointer. Okay, so as we saw in the wine source code, there's many window handles which are used by the Windows operating system. There's handles for fonts, for icons, for registry, Windows registry things, for bitmaps, for brushes, for Win32 GUI menus, for Windows stations, for windows, for palettes, etc. Resource for processes. Okay, we can see these Windows handles. There are a limited amount available on the Windows operating system, and we can see them using sysinternal suite Process Explorer. So let's look at those. Process tree system, where are you? This thing. So the Visual Studio main process has thousands of Windows handles in use. So it has Windows handles for files, Windows handles for events, directories, desktops, registry keys, threads, Windows stations, etc. And also the count of used Windows handles is available somewhere. Handles. So it says if I go properties on a process inside of sysinternal suite Process Explorer, in the tab performance, in the last group box, which is called handles, there's the total handles of this process, which is 2078, which is this process has never used more. And there's GDI handles, which are used for painting, for graphical user interface painting, which is 311. And then there are user handles 117. At least in the years prior, you needed to make sure that you're not leaking handles, because once a process, if the count of handles of your process keeps increasing, at one point your process will implode and be killed by the Windows kernel. Okay. And the .NET Framework Invoke machinery, the marshaller, knows how to handle HWNDs and convert them to int ptr, this native C# type or platform specific type used to represent a pointer or a handle. Okay. So in fact, this definition is okay with me. But then let's look at the last type, this uint utype. Okay, so this uint utype is defined in the section parameters at the end and says that it has some predefined values. Specify one of the following values, and it says mb abort, retry ignore, mb cancel, retry continue, mb help, mb okay, etc. Where mb okay, we have already defined it previously in here in message beep type. Okay, so let's make another enum especially for message box. This one was for message beep, this will be for message box. And type, the same thing, message box utype. The contents and behavior of the dialog box can be a combination of flags from the following groups of flags. Okay, so this thing is semi-flags. Okay, let's look at the smallest value possible. Here it's mb okay, the same thing. Then there's the value 1. mb okay cancel. So this says that this will be a message box with two buttons, okay and cancel. Okay. The next one, value 3, yes, no, cancel. Let's put a new line to separate what's already done and what's just copied. Yes, no, cancel this thing. Then there's 4, yes, no. This means that the message box will have two buttons, yes and no. Okay. 5, two buttons, retry and cancel. Okay. 6, Cancel, retry, continue. Okay, so there's a ton of them. Exclamation 30, yes. 30 is warning, information, and asterisk is 40. 20 is question, so these are okay. Stop, error, and the same thing as error. Default button 0 and be okay. Okay. So this is enough for now. Now we'll need to add some coding guidelines because this thing is getting out of hand. So let's do that. Look at fixcop. Traditionally, in the .NET framework, we have two static analyzers. One is called stylecop and the other is called fxcop. fxcop was replaced by .NET analyzers, which fxcop was an external executable, whereas .NET analyzers do static analysis on the source code using the .NET compiler, which is called Roslyn, the .NET compiler platform. Okay. So we actually need this guy. So this is the one, primary analyzer package for this GitHub repository, github.com/.net/roslyn-analyzers. This guy, let's add to the project as a NuGet. Browse, Control V, enter this thing. Latest table is okay. No dependencies. I agree. I accept. Okay, so we're using .NET Framework and .NET Framework 4.7.2 like this, which means that the CS proj is .NET Framework style and looks like it's huge. It's an XML and looks like this. Okay, and then there's a packages.config file. In this case, there's just Microsoft Code Analysis Analyzers version 7.01. Let's build the thing. It builds. Now we need stylecop. Stylecop is this guy. This is the GitHub repository, github.com/.NET analyzers, stylecop analyzers. Okay, there's more analyzers for WPF, etc. Documentation. Okay, there's NuGet version. rule sets. Okay, let's do that. Manage NuGet packages. Browse this guy. Install. Okay. And let's enable docstrings. So build and both configurations XML doc. Where are you? Let's make everything built into the top level directory. In here. Apply. Properties. All config. Where are you? So this thing should be for all configurations. Okay, and now we can do our thing. So XML documentation should be generated and treat warnings as errors. All we keep the default warning level. Okay, build, and now we get errors. So let's fix them one by one. Enumeration items should be documented. No, Invoke documentation item, enumeration items should not be documented in my opinion. Just search on the internet for, I did not rename the members. So it's extremely easy to search on the internet for MBOK with a message box. It will take you to the correct place. You will have the better documentation than me actually copying the documentation from Microsoft documentation in here. Okay, and when Microsoft fixes their documentation, improves the documentation, I will not need to copy the new documentation again to this enum member. So let's not do that. So suppress this thing in source. Okay, I need to do this for all of the enums, which I define while doing the invoke. What the heck? Control X. Okay, like this. Next. So this was SA1602. Next is SA1633. The file header is missing. No file should have file header. So let's do something. So I want to use editor config and file should have header in editor config, this thing. None. Okay, and the editor config should be top level inside of the solution directory, which it is. Okay. Control S. Let's build. Elements should be documented. Which thing? So let's fix this one. Element program should be declared with an access modifier because it's the entry point of a executable. This should be internal. Okay. What else? Using directive should appear within namespace. I agree. Like this. Ctrl S, F7. Closing brace should be followed by a blank line. Correct. Element main should declare an access modifier. I know. The lowest possible. Let's see if this thing still runs. No, because it does not build, because it has warnings. Let's do next. Says elements should be documented. No pinvoke elements should totally not be documented. If you want documentation for pinvoke, search on the internet. Elements should be in source. Okay, so elements should not be documented for pinvoke, in my opinion, because the documentation on the internet is better than the documentation that I could write. Okay, Ctrl S, F7. Elements should be documented. Yeah, this one is mine, so I could as well document it. But that will require some bullshit writer add-in for Visual Studio. So let's do that. Extensions, manage extensions. This thing goes to doc. Close, save. Modify. Okay, it says please close and restart. Let's see if the applications are stopped. So it's called devenv. Okay, let's start the application Visual Studio, which is the integrated development environment for C#. Okay, let's build. F7 to build in my case. Elements should be documented, Ctrl-Shift-D. What is this? Okay, this should be always a text. Useless text, okay. F7. Elements should be documented. No, these guys totally should not be documented. Okay, it's mega clear what the name of the function is. It's clear from which DLL comes. Search on the internet to find the correct documentation. Even the identifiers of the arguments parameters are exactly the same as the ones in the online documentation. F7, okay. And now we can run this thing. And it starts and it does its thing. Okay. So we know how to take from an existing DLL functions which are exported with C style. So if the DLL is written in C++, you need to use extern C. We know how to convert the two string types for the C programming language for Microsoft Windows into C# using this and this. We know how to convert Microsoft Windows style uppercase bool to C# bool, like this and like this. We know how to specify the DLL that should be loaded, the name of the function, how to use both an int or an enum. Like this, it will still compile and run correctly. We know how to convert a HWND, Windows type for Windows handles, into C# int ptr. C# int ptr has this static read-only field 0, which should be used instead of the literal zero integer. Okay, what else? We know how to handle get last error, set last error, like this and like this. Again, documentation should not be written for pinvoke. Okay. The next problem that we face is that there's no centralized pinvoke DLL inside of the .NET framework. So everybody, all of the various users of .NET framework, various developers, millions of C# developers, keep writing again and again the same pinvoke code. And if you have a large software organization which develops hundreds of products, then you will have the same definition of message box scattered in thousands of source code files, which is a problem. And the problem is called don't repeat yourself. Where are you? C2 wiki, this thing. Okay. Inadvertent or purposeful duplications. It's inadvertent. Nobody tries to copy the signature of message box all over the place in hundreds of DLLs, of C# DLLs, etc. But people actually do it. People don't actually search if this function user32.dll message box was already imported correctly and written correctly in C#. They just create their own either from pinvoke.net or from the Microsoft documentation. So the correct thing to do is to actually create a DLL which could only be named pinvoke. I'm not sure how you could name this DLL any other way, which is a DLL, where are you? Class library.NET framework, this thing. Again, it's named pinvoke, like this. You select the .NET framework, and then this DLL will not have any dependencies. This DLL will work correctly in any .NET framework application that you develop inside of your organization. Okay, these things need to be moved here. Okay, and let's see how we do it. This program.cs, it's doing two things at the same time, which is wrong. Files should do one thing and do it well. Classes should do one thing and do it well. Methods should do one thing and do it well, etc. So this is actually Invoke business, and then this is the world building executable entry point, which is static void main. Okay, the program.cs should only be concerned about this, not about random pinvoke. So this whole source code actually wants to get out of here and move away. Okay, let's fix the build issues. Control dot, yeah, F7. Okay. Elements should be documented. What do you mean? Okay. Then what? Okay, so we know what name we should use for this DLL, which contains pinvoke function definitions, enum definitions, and struct definitions, and nothing else should be named pinvoke. What should the individual classes be named? I name them by the name of the DLL that we use. So for user32.dll, the class will be named the same, but with the correct casing. Okay. Message box does not exist. Let's fix the issue. Add references. Invoke. Okay, and this should be let's rename so the class should be named user32.dll. Let's rename the file. Okay, Control S, F7. The class should be exported, so public class. Enums should be exported public enum. Functions should be exported public, static, extern. Okay, great. This thing should not exist here. I do not know the syntax. Like this. Okay. Elements should be documented. No, they should not because they're internal. I'm not sure how I fixed this thing. Put some documentation just in case. Okay. The next evolution from this is to split the types, the pinvoke types from the pinvoke functionality. In previous versions of Visual Studio, we had this warning generated where it says category Microsoft.design, CA 1060, move pinvokes to native methods calls class. So you should have a class named native methods where you move the pinvoke function definitions. So all pinvoke function definitions should be part of a native methods class. This might be a rule of the past, maybe CA 1060 is not the latest and greatest technique these days, but still I tend to use a class named native methods. So that's the only thing that you need to do is create a class which is native methods. Okay. So this is the next thing that I do. I put the functions into a native methods class. Make it public. And if we still have a native methods class, I have a similar class for enums and structs. Okay. So I document why I needed to create a class native methods. I do it because of CA 1060. Whenever the organization decides not to follow CA 1060, we could keep the class user32dll. I would totally not put into the same class pinvokes of functions exported from two different DLLs. So let's keep classes small and extremely easy to name and explain what the reason of this class is. So this class contains all of the pinvoke signatures for all of the functions that are needed inside of our organization, and the functions are exported by user32.dll. We only use two functions for now, so we only have these two here, message box and message beep. When we will need 10 more, we will add them, etc. So for the entire organization, it does not matter how many C# or .NET Framework projects we have. Whatever function we need to be invoked from user32.dll will land inside of this class, inside of this class. Okay. And this would be native types. F7. Now it does not find the types. I'm not sure what to do, either using static or inline the actual type. Let's do this. F7 to build, and then this is not available because we want more. We want native methods, and we also want native types. Okay, let's clean up. F7. The cleanup button is this one. Run code cleanup profile 1. Which profile 1 does format the document, sort usings, remove unnecessary usings, apply file header preferences, which I do not have such a thing. And it could also apply this dot, which we use in our organization. Okay, so back to the Invoke. Let's clean this up too. Let's add the NuGet packages for static analysis. Which are this guy. Okay, this guy. Let's see if it builds. And let's do the doc strings. All modules should build in the same directory, in the top level directory. Okay. Control C, all configurations, Control V, this, and save. Build. Okay. Missing XML comment for publicly visible type native types. Control Shift D. Some bullshit. Control Shift D. More. Okay. Missing XML comment for publicly. Where are you? This thing. Okay. Let's build this thing. Okay, so we have an editor config which only says style cop do not warn if files do not have a header. Then we have a solution with two projects, Invoke.csproj and another module. Okay. No need to put documentation again on Invoke enum members or enums or structs or functions. And when importing a function signature, an enum signature, a struct signature, make sure you're doing the very, very correct thing. So check the signatures in original C programming language and in the final C# programming language and make sure they're really correct and equivalent. Because in the end, you're going to have just one pinvoke DLL in the entire organization, and this is going to be used anywhere, everywhere. A central point where you define them, a central point where you fix bugs. Okay, so you don't repeat yourself. But then there's a force that acts against having such a pinvoke DLL, which is at least this guy, which says pinvoke methods should not be visible, which comes from Sonar C# Squid as 4200. This rule is deprecated. The worst rule ever. Why would you want to keep duplicating the pinvoke signatures? Again, nobody gets them correct in the first try, in the first year. So you will always have bugs and issues and things that you can improve in your pinvoke signatures. So do have them just once per organization in a single DLL, in a single class. Do not duplicate anything. Make them as good as possible. Make them usable in all circumstances. Make them bug-free. Maintain them, right? Do not just let them bit rot in some random C# module. Fix the issue just once in a central place. Okay. So class user 32.dll, class native types with two enums, which have a base type uint, and then a class native types with the two pinvoke function signatures, message box, and message beep. Okay, and the next step in here, if is to actually wrap functions that do not use C# style canonical types or idioms to make them be as canonical as possible. So there are, for instance, functions which you must call twice. First with a buffer and a size of 0, then it returns the actual size of buffer, then you allocate a buffer of bytes and you give as parameter the size of the buffer of bytes, and then it writes inside of your buffer and then it returns how many bytes were written. So that dance is way too involved and way too C programming language. So do wrap that dance into a C# function, a C# method. So let's look at some source code. Okay. So we have user32.dll, user32.dll, native methods, exported more than 2 functions, so show window, message box, find window, send message, show windows, async, set foreground window, set active window. Okay. In native types, more enums. There might be an enum with just one member. There might be enums which are of type flags, which is this message box type. It's actually flags because you can say message box OK, or message box icon stop, or message box system order. So these are groups. This is the group with buttons displayed. This is the group with icons. This is the group with modality, etc. So you can have a flags with just one of these, and then bitwise or just one of these, and then bitwise or just one of these, then just one of these, just one of these. Okay, message box result. And then in here we have a function which returns a message box result. And also throws. So you wrap the pinvokes into a bit more higher level C# methods. And you do that outside of the native methods and native types class. So inside of user32 DLL class, but outside of native methods and native types. So native methods is just functions that actually exist and are exported by user32.dll. Native types just enums and structs that are actually used by user32.dll. Whereas in here you can be creative, but not too creative, right? Message box get string. So this thing converts a message box dialog box command ID into a string because I needed to convert message box. Okay, so I needed to get from the Windows operating system and from Win32 API the string that will be displayed in the OK button. Okay, so I do this dance in order to get as a C# string the OK string from the enum ID OK. Okay, another one. So WTS API 32, this is a Win32 API DLL from the same place. This guy. And this is about Windows Terminal Services, so about RDP Remote Desktop Protocol, server, client, and additional functionality. In here, I did not define an enum, I defined consts inside of native types. Okay, so a ton of duplication, and I'm duplicating the documentation that exists on the internet from Microsoft, and I'm converting this thing automatically to this thing using the Visual Studio extension ghost doc. So again, I should not do this. I should delete this and mark the class that this class will not have its members documented. Okay, WTS info class, another enum, and then the functions exported, free memory, those functions with the prefix WTS. Query session, register session, register session. Okay, so because shell 32 DLL has way too many symbols exported, let's look at those. So as exported functions, it has, I don't know, thousands of exported functions. Not really. It has a ton. So sometimes you might want to split a class such as shell32dll in more classes. And there you can group them by the common parts, like shell execute in this case. So there's just shell execute and shell execute X as native methods. And as native types, there's the parameter of shell execute X, this guy. Okay, and then this struct has more types required, which are passed in here. So shell execute mask flags, which is, I don't know, this thing. Okay, anti-DLL DLL is this guy. That's its name, anti-DLL.dll. Has a class. And in here I did not use an internal class named native methods, which I should have. Or I do. Okay, so as native method, I have anti-query information process, so information about a process, which has types in here, and these are defined in here, process basic information. It's an enum, a struct. Okay. And then over this function, which is too low level, too C-like, too Windows C-like, I created as many methods as needed, as long as I keep them low level, just a bit of wrapping on top of the pinvoke function. So get parent process calls the native method to get the parent process. So it says basic info, which is a struct, and from basic info it looks at inherited from unique process ID, which is a member of process basic info, this thing. Okay. Get parent PID, get parent process ID, get parent process ID if you give it a handle, if you give it the process ID, it finds the process ID of its parent. Okay, by process handle and get parent of current process. Okay, net API 32.dll. This thing is about SMB, the Samba Windows shares, Windows remote registry, Windows remote service control manager, Windows remote printing, Windows remote registry. Okay, so DC get DC name, which says get domain controller name as DS means directory services, so Microsoft Active Directory. Net is the name of the DLL, Net API. So this is a common prefix for functions exported by Net API 32.dll. And this is buffer free, function which frees memory. Many DLLs have their own function to free memory. And there's heap functions for freeing memory, etc. Okay. As a native type, I needed this thing. Domain controller info. And flags. Okay, so again, the functions are too low level. So I do a bit of wrapping of the functions, because once you call DC get DC name, you must call net API buffer free at the exact correct place, only on the correct code branch. Otherwise, you risk leaking memory. Okay, so you call the native method, and if that succeeds, then it certainly has allocated memory for the struct, for the out parameter. Then you convert the out parameter, which is a int ptr, which means void pointer, to the C# struct, and then you deallocate the this buffer, which you have a void pointer to it. Okay. This thing, if it returns error no such domain, then it goes force rediscovery. So this is a cached way of searching the domain controller name, and this is a more thorough way of getting the domain controller name, but it takes longer. That's why you prefer the cached version. If that fails, you go with a thorough but slower one. MSI DLL. So you can see that the name of the DLL is msi.dll. MSI get product info. Control MO does this collapsing to definitions. Okay, so in here functions have the prefix MSI, and then I have a wrapper over 1p invoke function, which does what? Allocates a buffer of 2k bytes, and then calls the function and receives the number of bytes that were actually written to the buffer, and then you must trim the resulting buffer to that size. Kernel 32.dll. This guy. native types, flags, move file flags, process access, native methods, close handle, get console window, terminate process, move file x with this enum type as the last parameter, physically install system memory, query full process image name, open process. And then wrappers on top of these. Again, this dance where we use a string builder with some size. We receive the correct size, the number of bytes that were written to the buffer, and then we trim the buffer. Okay, this is for tool help DLL. th32cs. Module and process entry. Create tool help 32 snapshot. Is about Win32 API, not about the fact that it's 32-bit, because it's actually 64-bit. Okay, process 32 first and next. This iterates through the processes returned by the tool help snapshot for processes. And the modules iterates through the executables and DLLs that are loaded as part of that process. Add VAPI32. This thing. C:\, Windows, system32, add VAPI32. Advanced API. Is valid seed, logon user, Control MO. Lookup account name, lookup privilege value, LSA, close, add, NT status, open, duplicate token X, so security things. Security identifier. Token privilege, process token, thread token. So this is the Windows NT style security with tokens, duplicated tokens, process tokens, etc. Revert to self. Okay. And then for the winerror.h include file, I have h result value. So h result is a let's look at this. So win error is small integers, so 0, 1, 2, 3, 5, etc. Whereas h result has let's look at the documentation. H result is a set of bits, so it's an integer, 32 bits, and some of the bits from 16 to 26 are reserved for facility, 0 to 15, so the first 16 ones are an integer code, and then success 0 on the 30, on the bit 31, which is the 32nd bit. Success is 0, failure is 1. So you just look at the most important bit. If it's a 1, then this whole thing is an error code. Otherwise, it's a success code. Okay, so this behaves like a struct, but it's actually stored on an integer 32-bit signed integer. And I have a wrapper over this thing. Okay, and what do safe handles do? I'm not sure. Probably it auto releases something. Automatically close handle. Okay, so this is it. This is how to use the invoke in C# in .NET Framework, in this case, or in .NET Framework 4.7.2. Thank you.